So this is the second video. It's like the third day of the unit, but the second video in the unit, because it's applications of the fundamental theorem of calculus. So here's the fundamental theorem of calculus. That's what we just looked at in the warm-up. The antiderivative of a derivative gets you back to the original. Got it. That makes sense. And then plug in the top minus plug in the bottom. Now think about what this means. F of b minus f of a, that's the change in f from a to b. It's you can think of it as like the numerator of the slope formula, right? The change in y over change in x. F of b minus f of a. The other side, f prime, is a rate. And so this is a huge deal to think of it this way, because we ask questions that make you think of it this way. If you integrate the rate, you get a change in the amount. That's another way to say that. If you integrate the rate, you get the change in the amount. Integrate a rate, you get the change in the amount. So we'll ask questions like this a lot. We'll give you the change in the amount, or ask you for the change in the amount, and basically you end up having to integrate the rate. So if you know an expression for the rate of change of a function, right, also known as a derivative, and one of the values, you can find the other value because you can integrate the rate to get the change in the amount. It allows us to predict the future value as long as we know one value and the rate of change. Let's see what this means like in practice here. Examples. If f prime equals 5x to the fourth plus 10 of x, 10x, f of 1 equals 3, find f of 2. All right, that's a lot of information there. We're given stuff about f prime, and we want to find f. Here's how I think of this problem. I'm given f prime, I want to know something about f. So what should I do to f prime to get to f? Take the antiderivative. I'm given a derivative, I want the non-derivative, so let's take the antiderivative of f. And that should give me f, and if I look at which things I know, like which x values I'm using, 1 and 2, that gives me my limits, 1 and 2, so this would be f of 2 minus f of 1. If you integrate the rate, you get an amount. Okay, let's look and see what we know here. I can find this side. I'll have to take an antiderivative. I know f of 1, and I'm looking for f of 2. So I have everything in this problem that I need. In fact, I think I'm going to go ahead and move f of 1 to the other side. Let's don't do that yet. Let's plug in what f prime is. Let's take the antiderivative, and then we'll worry about f of 2 minus 3. Okay, so antiderivative of 5x to the fourth. That would be x to the fifth over 5. That's nice. X squared over 2, so that would give me 5x squared from 1 to 2. Restart my problem up here. So it would be 2 to the fifth plus 5 times 2 squared minus, again, make sure you get all of it, 1 to the fifth plus 5 times 1 squared. Let's see, that's 32 plus 20 minus 1 plus 5 is 6. So 52 minus 6 is 46. Yeah. And that all of that was equal to f of 2 minus 3. So move the 3 over. F of 2 equals 49. You integrate f prime, you get stuff with f. Like, that's all we're doing. If you take the antiderivative of a derivative, you get back to the original. Now, number 2 says calculator. So let's pause right now and grab a calculator. Either get one of yours out or some of mine are floating around, so grab one of them. All right, as usual with calculator problems, do not grab your calculator right away. Right? Like, set up the problem, figure out what you're doing, and then see how the calculator can help you answer it. If g prime equals this ugly thing, and g of 5 equals 2, find g of 1. Okay, so again, they're giving me g prime, and they're asking me questions about g. So what should I do to the derivative to get back to the original? Another antiderivative. If I'll antiderivative g prime, that will get me something with g. And again, the rest of the problem tells me what limits I should use. So 1 and 5. And that would be g of 5 minus g of 1. I mean, you could use any limits you like, but since we're given information about 1 and 5, we should probably be using 1 and 5. Okay, so that's the antiderivative from 1 to 5 of e to the negative sine of x dx equals 2 minus g of 1. All right, well, the calculator can do the antiderivative of e to the negative sine of x. So math 8 was the derivative. Math 9 is, so it says FNINT, function integrate. And if you press enter, if you have the newer version, which you should, if you're using one of my calculators, they should all be updated. It looks like that. If you don't have a new version, it gives you something that's hard to mess with. I don't have a calculator that shows it. So use one of mine. It's a whole lot easier to know what goes where. So we're going from 1 to 5, e to the negative sine of x dx. And who knows what that is, but the calculator can do the calculation for us. 3.797, always 3 decimals. So let's see, it's a little algebra problem here. Uh-oh, some of you are looking at that, not right? I wonder if I'm in radians versus degrees. Ah, there it is. Got to be in radians. So let's try that again. Does that match your answer now? Okay. 4.970. Okay, so I'm going to move the g of 1 over and then subtract the 4.97. So 2 minus answer is negative 2.970. So it was the same thing as number 1, but instead of us doing the antiderivative stuff, the calculator did it for us. Tyler?
My calculator errored out.
Number 3, calculator problem. Let h of x be an antiderivative of this ugly thing. Let h of x be an antiderivative of that. Well, that means that it's a weird way of saying that a derivative of h prime would be exactly that. He's trying to get us to think a little bit there. If I took a derivative of h, I would land at that thing. Okay, now it's just like number 2. uglier, but the calculator's doing all the work. H of 7 equals pi, so that's fun, I guess. The antiderivative of h prime, and then we'll use 3 and 7, equals h of 7 minus h of 3. Now it really is a calculator problem, because the calculator is going to do this, and I'll have to move some things around to get h of 3. Why don't you try that one, see if you can come up with what h of 3 is. Negative 16.472. I don't want to gloss over this first step. Super important. Some people, they try to skip that step and sort of jump into the problem. It's like jump straight into the calculator. And then they end up messing up, like, well, what do I add? What do I subtract? They mess up the little algebra stuff because they didn't write the main thing first. So maybe that seems simple, but I think that will save you a lot of mistakes if you will take the time to write that out. I mean, it's pretty basic. The antiderivative of h prime gives you the change in h. But that helps you sort of start the problem, helps you see what the calculator needs to do, helps you see who gets added and subtracted and moving things around. Number 4. If the antiderivative from 2 to 9 of f prime is negative 1.6, f of 2 is 3, what is f of 9? Okay, this one in some ways is like easier than the others, because it, like on number 1 we had to do the work. On number 2 and 3 the calculator had to do the work, and by the work I mean the antiderivative. But on this one it just gives us the answer. But again, I would write out that main statement first and then plug in the pieces. Because if you don't write that out, chances are you're going to end up adding or subtracting something wrong. So the antiderivative is negative 1.6. F of 9 is what we're looking for. F of 2 is equal to 3. And so all I really have to do, like the math on this one is easy, add 3 to both sides and get 1.4. So like, yeah, I guess it's a calculus problem. You didn't really do the calculus, all you had to do is add. But if you don't write this first statement out, people are going to do 3 minus negative 1.6 and negative 1.6 minus 3, and there are going to be all sorts of answers that aren't 1.4. Number 5. Okay, this looks like an area problem, so we have to remember that the antiderivative of g prime is the area under g prime. So I hadn't even started the problem, and I bet that's what this is about. The graph of g prime, shown on the right. If g of 3 equals 7, find g of 0. So I know I'm going to want an antiderivative g prime to get to g. That's the whole point of this. What limits should I use? I got lots of options here. Negative 2, 0, 1, 3, 5. What are my limits for integration going to be? What should I use to make this problem work? You don't know if you're just being quiet. So, Bryce, what limits should I use?
1 and negative 2.
Okay, that would tell me the area of the triangle. But look at the other information that the problem gives me, and what I'm looking for. So it tells me g of 3 is 7, and I want to know g of 0. So those are the x values that I want to use. So let's use 0 and 3. So it gave me far more of a graph than I needed. I'll go from 0 to 3. I guess that's kind of annoying because it's a triangle plus a fourth of a circle. So I need the area from 0 to 3. So triangle plus a quarter circle. 1/2 base times height. 1/2 1 times 3. plus, it's a fourth of a circle, 1/4 pi times r squared, equals, I guess I should have filled this in over here, g of 3 minus g of 0. The g of 3 is 7, and g of 0 is what we're looking for. So 3/2 plus pi equals 7 minus g of 0. So now it's just some algebra things. I'll move the g of 0 to the left, move this stuff to the right, and end up with 7 minus 3/2 minus pi. And why in the world would I do anything other than that, right? Like, leave it alone. Yes, 7 minus 1.5 is 5.5, but why bother? Again, that main first step, the antiderivative of derivative gets us back to the original, and then use the problem statement to figure out what limits to use, what boundaries on the antiderivative to use. All right, number 6. It's one long problem. G prime is defined on -2 to 6. The graph of G prime is shown on the right, consists of 2 line segments and a semicircle. It is known that G of 1 equals 5. Okay, that's probably going to matter somewhere. Find G of -2. Well, first of all, G of -2 is probably not 1, right? G prime of -2 is 1. But to find G, when I know G prime, I need to antiderivative G prime to get to G. But again, the question of what limits should I use? So what needs to go here and there? So what x values should I use for my limits? Definitely -2, because that's what I'm looking for. And we know G of 1. And then let's put them in order. -2 to 1. So G of 1 minus G of -2. G of 1 we already know. And this integral is an area. So the area from -2 to 1. Oh, that's not bad. That's just one triangle. So I'm not even to the circle yet. So that would be 1/2. Base is 3. Height is 1. G of 1 is 5. G of -2 is what we're looking for. So G of -2 would be 5 minus 3/2. I could leave it like that. If that's annoying to you, 5 minus 1.5 is 3.5. Equally acceptable answers. Find G of 5. Okay, well, kind of the same problem. The antiderivative of G prime is going to give me G, but the question is, what limits should I use? So what limit should I use if I want to find G of 5? Okay, there's actually 2 good choices here. I definitely want to use 5 because I've got to know what G of 5 is. And then, yeah, I would just use 1. I don't know that anybody would go back to -2. But since you know what G of -2 is, you could use -2 as your lower limit, but probably easier to use G of 1. Since we definitely know what G of, right? Use original information when you can. So let's use 1, because I definitely know that G of 1 is 5. Let's see, the area from 1 to 5. Let's see, that would be a half a circle. What's special or different about that half a circle? Careful, yeah, it's below the x-axis, so the antiderivative is negative. You could still say the area is positive, but the antiderivative is negative because it's below. So negative 1/2 pi times r is 2 r squared. So negative 2 pi is that. Oh, careful how I phrase that. Negative 2 pi is the antiderivative from 1 to 5. The area is 2 pi, but it's below, so it's negative. G of 5 is what we want. G of 1 is 5. So it's kind of an easy one. I'll just add 5 to the other side. Whoops, I'll add 5 to the other side and get 5 minus 2 pi. Let's skip C just in the interest of time, but it's the same thing. It's the integral of G prime. You definitely want to end at 6 so that G of 6 shows up. But that other one, you kind of have options now. You could go back to 1 because you know what G of 1 is. But you could also use, what else could you use that would be a little easier? You could use 5 because I now know what G of 5 is. And if I use 5, then the only area I would need is that little triangle right there. So probably best to use 5, but if you went all the way back to 1, it would be fine as well. You'd be repeating some of your math. All right, what I wanted to get to, find the value of x at which G has a relative minimum, justify your answer. Oh, this goes back a ways here. G has a relative maximum. Okay, we ought to be able to answer this question without any picture or without anything. Like I should ask you to justify that without anything. How do you know where G has a relative maximum? What would you be looking for on G prime? Positive to negative. Hand motion is required, right? G prime changes positive to negative. So there's our justify, already done. Justify. Yep. Now, where does that happen? So we look at our picture. Our picture is G prime. So where does our picture, where does our graph change from positive to negative? At 1. Good. I'm not looking at the slope. I'm only looking at where does the graph change from positive to negative. So that happens at x equals 1. Find the value of x at which G has a relative minimum. Okay, so same but opposite, right? G has a relative minimum when G prime. I should probably just change those, but I want to think about it again. So minimum, that's a valley, so G prime's going from negative to positive. G prime changes from negative to positive at x equals 5. My graph crosses from negative into positives. Point of inflection. Justify your answer. G has a POI when... Okay, the first thing I think of with point of inflection is G double prime changes signs. That's a true statement, but it's not exactly helpful for this problem because I don't have, directly anyway, any information about G double prime. So what's another way to say G double prime? The derivative of G prime, I'm going to say the slope of G prime. the slope of G prime is the same thing as G double prime. And now I know what to look for. The slope of G prime changes signs. Okay, my graph is G prime. So where does the slope change signs? X equals what? What was that? 3. It's negative, negative, negative. Something weird happens here, but it stays negative at x equals 1. So negative, 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 negative. At 3, it changes signs to positive. Something weird's happening at 5, but the slope of G prime doesn't change. It's still positive. So at x equals 3. Alright, find the absolute max and the absolute min between negative 2 and 6. So that sounds like a table of values thing where I need my relative extrema and my endpoints. So my endpoints are negative 2 and 6. My relative extrema, that's what I already found. That happened at 1 and 5. And then if we look back up at the top, this is probably an old AP test question because this is what they like to do. I need to find G of negative 2, but I already found that. That's 3.5. That was part A. G of 1 they just gave to me. That was 5. G of 5 I had to find. That was 5 minus 2 pi. And I punted on G of 6. Let's go back and let's see. That extra area is only 1. So G of 6 is 1 more than G of 5. So that's going to be 6 minus 2 pi. That was kind of quick, but you could go back and do it if you want to, or just trust me. So G of 6 is 6 minus 2 pi. Uh-oh, now I've got a little bit of work to do because I need to find which one of those, let's see, is the absolute max and the absolute min. I guess the first question is, what am I looking for? Am I going to give the x value or the y value? I know I'm looking at the y value because that tells me who's max and who's min. But is my answer going to be the x value, where it happens, or the y value, what it is? Find the maximum, find the minimum. Those are the y values. So it doesn't ask me where they happen, it just asks me what they are. Okay, I'm going to need like a decimal equivalent here. And I hope these are close enough. 5 minus, let's see, pi is 3.14. So 2 pi is 6.28. I'm hoping this is close enough. 5 minus 2 pi then would be negative 1 something. How's that for math? Negative 1-ish. 6 minus 2 pi. Oh, that one's easy. That's negative 0.28. Okay, so now I can get my... easier to compare now. Alright, so my absolute max is 5. Now, you can say that it happens at x equals 1, but that's not what it's asking. The absolute max is 5. And the absolute min is that negative 1-ish. That's not a good answer. Let's say 5 minus 2 pi. That happens at x equals 5. That's not what they asked, but if it's certainly what they could have asked. You know, where are the local max, or where are the absolute max and min? All right, a little combination of stuff there on that last page. So the next worksheet is worksheet number 3, I think. Applications. Nope. Worksheet number 2. And if it looks crazy, use a calculator. That's the short answer. It doesn't say directly that. It kind of says that. a calculator is required for some of these problems. So like number 1, you're going to be anti-derivatizing the cosine of x cubed. You're probably not doing that by hand. That's a calculator problem. Same thing with number 2, same thing with number 3. Number 4, it just gives you the answer. That's nice. Number 5, I guess you could do that by hand, but it doesn't say not to, so I would just say use a calculator on worksheet 2. That would be the easiest way to go. Sometimes it'll help, sometimes it won't, but use a calculator for worksheet 2. And we'll see how it goes tomorrow. We have lots of time built in for review. So I'll definitely answer questions from worksheet 2 tomorrow, and then we'll see if we get to worksheet 3 or not. If we don't, it's fine, because we got 3 days built in for review worksheet. We'll easily cut that to 2 and be just fine. But don't count on that. Try some of worksheet 2 tonight so we know what to talk about tomorrow.